Let's start. Now what we are going to do is we are going to classify the bacteria. As I said, you know that some bacteria need little oxygen, some bacteria need not a little, even no one oxygen. Okay, if they will get the oxygen, they will die. Some bacteria, they need like mediocre. Okay, and there are certain bacteria, you give the oxygen, they will happy. If you not give the oxygen, they also be happy. Fine. And there is one category of bacteria who only be happy when you give them the oxygen. Okay, so on the like in this ways we have the 5 categories. We have the 5 categories. So before going in detail of this 5 category, I want to grab your attention and you just pay attention here. How we are classifying this bacteria in the lab. Because in the naked eye you cannot see that, okay, this bacteria you are aerobic, this bacteria you are anaerobic. No, you need a proper, you can say, the technique by which you can able to differentiate these 5 bacteria. So for that technique we are generally employing one type of test. Okay, one type of test that is called as the differential culture media. Differential culture media. Why it is called as the differential? I will teach you when we will discuss the media, probably in not tomorrow, day after tomorrow class. I will teach you about the media because it is in your syllabus. Okay, and what is media? Nutrition. Okay, nutrition which we are going to provide for the bacteria. Okay, yeah. So this is a one kind of differential media. This is one kind of media, and why it is called as differential? Just because we are by using this we are dividing the bacteria. We are dividing the bacteria. That's the one thing. Second thing is that in this differential culture media we are using certain chemicals. We are using certain chemicals. Okay, and those chemicals, based on those chemicals name, this differential culture media is called as, yeah, it is called as thioglycerate broth liquid media. This is the liquid media. So thioglycerate broth liquid media. We taken the plain test tube. Now this plain test tube we have to make in such a way by which when we take the bacterial sample, okay, and we put it into this tube, we are able to differentiate. Okay, so we have to make this tube in such a way. So for that we are adding something to it. Okay, the first thing which we are going to add is thioglycolate. 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 Second things which we are going to add over here. Okay, second thing which we are going to add is the agar. Okay. Third things which we are going to add here is the oxygen and indicator. And that oxygen indicator is called as resazurine. That is called as the resazurine. And then we will add here basically the nutrient. Okay, nutrient, and that nutrients we are calling as a broth. Okay, the broth meaning is basically a nutrient. Fine, so nutrient, or you can write it as a broth. Okay, this broth is nothing, it's just a amino acid. Okay, the what bacteria prefer to eat is a glucose. Okay, glucose and rest of other things. Fine. So first things we are adding the thioglycolate, then we are adding the agar, this resazurine, and then the nutrient, both are amino acid and sugar we are adding. Now each one of serves for a different purpose. Fine. So for thioglycolate, why we are adding the thioglycolate? To make the anaerobic environment. Fine. Whatever tube you are taking, then there is a chances कि उसमें oxygen present होगा. There is a chances to have the oxygen here. Fine. So for testing purpose, we are going to make absence of oxygen, no oxygen, free oxygen environment inside the tube. So for that purpose, we are adding what? We are adding the thioglycolate. No problem. Then we are adding the nutrient, because bacteria will only grow when they found the nutrition. Okay. If you're not providing the nutrition, bacteria won't grow. Not grow. Fine. So for that we are using the nutrient broth. Then we are adding the agar. Okay, we are adding the agar for again making the free, no any oxygen and no any other microbial growth. Fine. Then we are using this resdurine. This resdurine is basically oxygen indicator. It will show when we will add this in the tube. Fine. When we will add this in the tube, then it will show that there is a presence of oxygen in the tube or not. Basically, this is act like as a oxygen indicator. Now the game is the start. You know the wound? Yes. Wound. You know the abscess? Not know. You only know the wound. Okay. Abscess is basically the pus formation in the wound. Okay, pus formed in one area, that is called as the abscess. Fine. So but through the aspiration, we take in certain samples. Okay, we take in certain samples. First we made this. Once we made, first understand about this tube. Once after giving all these things, our tube becomes like here. There is the most of the oxygen present. Silent your phone, bro. Yeah, from here most of the oxygen is present. How much oxygen is present here? Because this is open. What do you think? Where oxygen is more present? Upper side? No. It's a 21%. Okay? 21% oxygen is present here. Get the point? Now, as you go inside, the oxygen concentrations become less. Why? Because we already added this thioglycolate and for removing the oxygen, making the anaerobic environment. Fine. So as you go in, you can say deeper, there is a less oxygen. Suppose here is the 21%, then here there is a 10%. Fine. Here 5%. Here 1%. And down there is no oxygen. Zero. Absolute zero. Getting the points? Yes? Yes? Yeah. For that purpose, we are added no thioglycolate. That make no oxygen. Okay, initially in the tube there must be some gases is present, there must be the oxygen is present. So we are that's why we are provided the thioglycolate. Okay, it basically remove the oxygen. It's remove basically the oxygen. Thioglycolate. It is a reducing agent. Write it down. It is a reducing agent. Clear? No problem. Now we take the sample. We taking from the localized pus, that is called abscess. We taken certain through the aspiration. We taken certain sample and we put these samples here. Fine. Then the bacteria which loves oxygen, they are called as the strict aerobes. So they will concentrate here only, because here the oxygen is present more. Fine. Then the bacteria who love oxygen like mediocre, okay, they need a very minimal range of oxygen, then they will grow here. Are you understanding? Yes? Why they will not grow here? because अगर आप उसको ज्यादा ऑक्सीजन दे देते हो, if you provide the too much oxygen, they will die. So the strict aerobes who need who need oxygen for their survival, they will grow in the upper part of the tube. Okay, upper part of the tube. The bacteria who need a mediocre amount of oxygen, they will grow in this mid part. Okay, the bacteria who need oxygen, or if you provide the oxygen, they will happy. If you not provide the oxygen, they will happy. Then they will grow in this side. And the bacteria who do not need oxygen at all, if you provide them a 1% of oxygen also, they will die. Then they will grow at this bottommost point. This bottommost point. That is how we are differentiating the bacteria. Clear? You have any doubt? No? Now let's apply this concept over the classification of bacteria. Fine? Fine.